Hello everyone, welcome to Let's Code. In today's video, we are going to learn how to implement Retrieval Augmented Generation, also known as RAG, using Spring AI and PGVector database. We will start by understanding what is RAG, purpose behind RAG, and at last we will implement RAG application using Spring AI. AI models like Gemini, Claude, ChatGPT are great, but they are limited to public data. They can't answer questions about confidential or non-public data. The Retrieval Augmented Generation or RAG is a technique to this common problem. If you are building a tool to helping customer with your product or an internal tool for company specific data, you can't use public AI models directly because their knowledge is limited to public available information that they are trained on. RAG gives us a way to give this AI a repository of our specific information that it can use as a reference to answer questions or generate information. So today we will build an application that will implement an entire RAG pipeline, and by end of this video you will be able to build an Spring Boot application which can take a user's questions and give back an AI generated response using your own private data source. Have you ever wondered how the AI model understands the meaning and relationship behind words? The magic behind this is concept called vector embeddings. In simple terms, it's just a group of numbers that form a numerical representation of data. In this case text, you can think of it like a special translator. You give it a word or sentence and it translates that text into a list of numbers which will make up our vector. The cool thing about this that these values are actually meaningful. So words or phrases with similar meanings have vectors that are numerically closer to each other. In real world, these vectors can have hundreds or thousands of dimensions, but to make it easier to understand, let's imagine a model that creates vector with only two dimensions, so we can plot any text on a piece of x and y graph. So if we had to plot vectors of dog, car, pet, and automobile, the points for dog and pet will be close, and car and automobile will also be close as well. This is how the model understands that dogs are pet and cars are automobiles. The distance between any two vectors shows how closely the two pieces of text are. So how do you create these embeddings? For this you will most likely need an AI model that has trained for this purpose. While you can use the paid APIs for this, the great news is that we can run powerful models on our own local machine for free. There are several tools that we can use for this, but the good one to get started is LM Studio. We will search in Chrome for LM Studio and click on the first link. Then we will go to the download section and provide the operating system information, architecture, and LM Studio version and click on download. Since I already downloaded, I will simply open it. Once we open the application, we can use search bar to find and download different embedding models. For this I am going to use Nomic text embed models. I'll download the model from here. Once the model is downloaded, I will go to the server tab and then search for the embedding models I just downloaded and start the server. This will create a local embedding model that we can use in our application. Now we will test our local server with curl command and get the embedding from some sample text. We have got the result with embedding vector. This model have created a vector with 768 dimensions. We have created embeddings. Now we have to store it somewhere. We can use any vector database. For this I am going to use PostgreSQL, a very popular open source database along with PGVector extensions, which will add the capability of vector similarity search to PostgreSQL. Now for installing Postgres, I am using Brew. You can also install this via postgres.app. Once this is installed, we will start PostgreSQL service and connect PostgreSQL database. So now let's create our database named DemoRag. We will connect to DemoRag and enable the PGVector extension. Then we will enable extension store to store JSON data. We will also enable UUID extension. Now we'll create a table to store vector data named vector data. Our table will have ID column, which is UID, automatic generated unique string of characters, the content, which is a raw text, and metadata in JSON that is used to store additional information about the content. And then we have embedding vector, which will store the vector data generated from our embedding models. Here dimensions should match the dimensions of vector generated by embedding models. At last, we will also create index on the embedding field to make similarity search efficient. Now we have configured the database for our application. Let's create a Spring application. We will head over to Spring Initializer. Here we will select Java and Maven version as default and give the project name as Rag Demo. Now we will add key dependencies for our application. We will add Spring Web for accepting any web request. Then we will add OpenAI starter dependency to connect local embedding models and online chat model. And then we will add PGVector dependency to connect to our vector store. Let's generate our project and open it in IntelliJ IDEA. Let's see pom.xml. Here we have Maven version, artifact ID. Let's go to dependency section. Here we have Spring Boot starter web dependency, Spring AI vector store, Spring AI starter model OpenAI, starter vector PGVector. Here we also have to manually add netty HTTP because our OpenAI model uses web client which is non-synchronous. Now let's open application.properties and configure PostgreSQL database connection. Here we will provide the Spring data source URL, username and password. I have commented this because our database is not using any password. We will also specify driver class name. Now we will configure our embedding model which is running locally from LM Studio. We will provide base URL from embedding model. We won't use key for this as we are running locally. Then we will provide embedding option model name as nomic embed text model. Then we will define embedding dimensions. Let's configure the properties from OpenAI chat model. Here we will give base URL and provide API key. This we can get from platform.openai. Then go to settings, API key and create a new one. Since I am already having, I will give it here. Then we will also specify the model as GPT 3.5 Turbo. Now let's configure PGVector configuration. We will give index type as HNSW, hierarchical navigable small word, a graph based algorithm for efficient nearest neighbor search in vector space. Then we will give distance type as cosine distance. Then we'll provide dimension as 768. We'll give max document batch size as 10,000. Schema validation as true. And at last we'll provide the table name as vector data. Now we have configured our application.properties. Let's create our first class document loader, which will implement command line runner. Here we will inject vector store and then implements the run method of command line runner. This method will create a document context which will work as content outside of the model, and we can query any information about this document to chat model. Here I have defined some Google search components like crawling, indexing, ranking, page rank, query processing and caching. Let's set these documents into vector store. Now let's create a new class rack service. We will annotate this with @service. Then we will inject chat client and vector store from Spring AI. We will create a static resource rack from template. and keep the path as class path prompts rack prompt. We have defined rack prompt template here. It asks AI to answer the user's question based on the provided information. Now create a method retrieve and generate. It contains the core logic of searching and responding, where we will give message as parameter and the search for the similar documents using vector store.similarity search method. This will convert user questions as embedding and retrieve the most similar documents from PGVector database. Then we will collect all the documents and join them as a single string. Then we will create prompt with help of static rack prompt template and provide the retrieved information and user provided message to prompt. And then we will call the online model and return the response of AI model. Now let's create a new class rack controller. We will annotate with the @rest controller and then define the rack service variable. We will inject it using constructor and then define a post mapping as AI/rack mapped to generate function. Here we are taking message request which is JSON request body. Let's define this message request record. Then return rack service dot retrieve and generate and provide request dot message as input. We have forgot to add that component in our document loader class. Let's add it here. The main application only contains main method to run the Spring application. Let's check the vector data table and it is empty now. Now we'll run the application and see in log that our documents are loaded into vector store. Let's check again this table. Now we have got the vector data in table. We can see content and embedding on the table. That is not very readable. Now let's make a curl request to our application and ask what is query processing, and we'll get proprietary information. Although this data is publicly available, but we can store any private data in our vector store. What is happening here is Spring AI retrieved these information from PGVector database and send them to OpenAI 3.5 Turbo model along with our question. Then model generated this response. We have also logged with println statement. Let's see what information we have got. We can see it has fetched some information each with score. Document with the higher score is the document mentioning about query processing. The score here shows how relevant a particular document is. Although it has worked well for our use case, but in production environment we have to keep in mind that large document might fail. To handle large document, we have to split the data into smaller parts. This process is known as document chunking, and each of these small parts can be saved as separate document. Another thing to keep in mind is embedding model. However, nomic embed model works well, but it should understand the meaning of your documents. You can experiment with other open source model or paid model like OpenAI Gemini. So that's it for today. I hope you have got some useful information. Thanks for watching. I'll see you in my next video.